Okay. All right. Well, welcome everyone. Welcome back. Spring 2025. Pretty crazy. Um, so this is pretty much our Tuesday lab class. Um, I just to give you a quick background, and then we'll kind of get going. I think there's like 18 or 19 in here, and it would be better off if we split it. So that's why I split Tuesday and Thursday. But if you prefer, we can, if you want to do Thursday, you can't do Tuesday, just let me know and we can switch it. Or if for some reason you forget, just come Thursday, okay? But I think it's pretty even, like eight and nine, I think, Tuesday, Thursdays. Uh, the this is my first time teaching it, and pretty much the overall first time it's really been on the books. Mr. Haskins has taught it a few years ago, but it was kind of an infancy stage. And so there's still some kinks being worked out, but the way I want to do it is kind of what the syllabus had. I might add a few labs here and there. Um, but right now, there's actually two labs on Brightspace, and I'll show you those. And you can get going on those. I'll kind of review them. But the first lab is make sure you're ready and prepped for memos, a full lab report, and there's another one that's like a shorter lab report. It's in between a memo and a lab report. Um, some of you have taken fluid power, so you've done some lab reports, but we're going to do a combination, and I'm not going to overwhelm you with lab reports every week. There might be some memos. There might be just, hey, just give me the data and analyze the data and give me whatever, and then we can combine it later on in a full report. But again, this week, I'll show you the assignment is just to get you formatted for those. Next week, there's a lot of students that are in taking strengths right now. So there's some basic equations that I'm going to go through, and you're going to do in Excel. And actually, some of you took my winter class. You already know how to do that. So technically, if you want to do it, hand it to me, and you're good. I'm okay with next week you missing it because you would have it done. But come in if you still want to. It's fine. Then the goal is I want to do data acquisition lab, which isn't on the syllabus, but I think that's important. We're going to look at temperature sensors because that's highly used. And then I want to get into simple machines, and then probably a fluids like Bernoulli's, a Venturi, and then get into statics problems, labs, strengths, and then materials. And then probably we might, depending on how many weeks we have left, I'll try to do some sort of design project. But me adding a few labs, we might just do labs the rest, and maybe that'll be something we do next year with different students. Um, in did anybody do anything with the Venturis from fluids at all? The Bernoulli's, like we have these big tanks with a pump, and these little cylinders stand on top. Some of you, I don't know if you've done that, but does anybody know what I'm talking about? Okay, you did that. Did you do that in fluid power? Get the chat. Yes, fluid power. Okay. Okay. All right. So, um, but some of you may not, or we can, maybe it'd be a good review. We could do that, and I can do another fluid problem. Did you do anything with hydrostatic forces in fluid power? That could be a lab that I could do. That would be a good lab, and we have that. I know with fluids, you talked about hydrostatic. Did you do a lab with hydrostatic forces? You know? Yeah, only in fluids. Okay, okay. So that's kind of where I wanted to see what you've done and what you haven't. Um, so we'll do some. We'll probably do Bernoulli's as a review, and then we'll do hydrostatics. We'll do data acquisition, temperature sensors, and then we have these. They're like Pasco bridges. If you go into the materials testing lab, which is 110, you'll see them. They're up on a shelf. They have it's basically a truss. We can throw sensors on there and we can load it and we can measure it. So that would be a great review of statics when you did trusses. So we'll do statics. There's another statics problem that I want to do, and I can't remember what it was off my head right now. But when we get to strengths of materials, we're gonna we're gonna look at the stress and strain. We're gonna grab a specimen and stretch it out and look at deformation and all that, stress, strain, find the modulus of elasticity. We'll also do the impact testing, which is like a pendulum that rotates and hits some sort of like square stock of aluminum, steel, and we can look at the hardness of that. And then materials, we'll do a few different things with materials. We might look at the structural components, or we will look at the different types of stresses and stuff inside those. Um, and let me see, do I still have that on me? I wrote some other things down, um, but I think we start with these first few, and the goal is hopefully you finish the lab part and you get majority of the analysis done. There's going to be times where you got to write this memo or you got to write this lab report. Um, but I'll give you like the lab report won't be due in a week. It'll probably be a couple weeks. And you might actually give me a draft in 2 weeks. I'll edit it and then give it back to you to fix it. But I won't give you full lab reports every week. There's just no way we can do that. So, but that's the goal. Every Tuesday from 1:30 to 3:20. We might get out early, depending, but I will provide you with information. We'll do the lab, and we'll go from there. So, are there any generic questions before I show you some other things? I think. Uh, see who is everyone. Everyone's either taken stat or either in strengths right now or have passed strengths in machine design, right? I think.
Taking that now.
Have you taken statics, Isaiah?
I'm in statics right now.
Okay. Hmm. Did I put you in this course?
Dr. PS did.
Hmm.
I have engineering materials with him right now, and then I have this lab and statics.
And statics. Okay. All right. There's going to be a few labs. Um, so some of the statics, actually, that's good that I'm waiting to do statics because you're going to be like, okay, what is this? And then strengths, you'll kind of get ahead. So it's totally up to you if you want to stay in this. It's fine. Um, or if you feel like you want to take it a different semester, that's fine too. But I'm game whatever way you want to do it. Okay. And I think everyone else, uh, Isaac, I don't know if have I met you before, Isaac? Sure if you heard me. Mitch, Mitch? Have you taken machine design or is that this fall? Can't remember.
I don't think I haven't taken it yet. I think it is this fall.
Okay. Oh, yeah, yeah. Okay, okay. All right. I didn't catch the last name because you were unverified. Sorry about that. So you must be on a web browser too, right?
Me?
No, not you, Isaac. Sorry, Mitch. Okay, okay. Sorry, Isaac. Now I know. Okay. Let's see. All right, let me share my screen. Some of you are familiar with my bright space, but let me just show you. Okay, I think yep, should be good. Okay, so when you click MECH 221, it'll come to here. I should update some of this. I'll try to remember to do that, but click content. And then once you click content, it'll actually have all of this information on here. Okay. So the communication manual is something you want to grab, which some of you probably know. But you can go ahead and download this, and I will download this because I want to show you what you need to do for Lab 1. And then there's some writing help. Whoops. Here in this section. Then there's the bare bone presentation, bare bone report. You won't the report when we do stuff, but you're going to have it already ready after this first lab. So that's information on there. There should be. Let me go back into content. Should be, yeah, here we go. Here's the syllabus, some programming tutorials, homework format. This is a reference handbook that I would highly recommend grabbing. Some interpolation examples, some cool little simulations, differential equation video help, conversion, and then just some cool things that you can download to check out. Okay. So this is always like the bare bone things that I have in each one of my courses. And then over here on the left, you'll have labs, and then I'll put lab 1 and 2 and 3 and so forth that we do here. Okay. So let me, so you got 2 labs already. I just figured I'd get ahead of the game here. So let's download that one. And let's go ahead and open that. Okay. So each lab will basically give you an overview, objective, submission, what you need to do in your tasks. Okay. So for lab 1, what you're going to do is you're going to grab this communication manual, and what you're going to do is you're going to make 3 documents. You're going to make, where is it here? You're going to make a memo type lab report, a letter type, and then a full lab report, and it's going to be outlines. Okay. So the cool thing is, so say you wanted to create a new blank document, you go to here, and then up here, you can click like, okay, heading 1, and then you could type something. Okay. And if you notice over here, there's a navigation pane. I don't know if you know this, but you could turn that on and off by going to view, navigation pane, and checking that on and off. Okay. And then you can click enter, and then say you want a subheading, and then say this is subheading whatever. Okay. And then over here, you click on these, and these will go right to that page. So here, you can go here, you could say insert page break. This will go down to the next line, or next page, sorry. So if you do click that, it'll go right to here. Okay. Now, if we open up, let me grab the manual. So here's the communications manual that's online. You can actually scroll all the way down, and we are looking for these: full lab report, a letter lab report, and a memo. Okay. And what I want you to do is pretty much copy the outline not the stuff inside. You'll see. So what page? Let's go down to a memo. So 25. Which I have right there. Okay. Sure, we'll do this letter first. So here is the letter lab report. Okay. What I would do is read each section. And then here, what you're going to do is you're going to have a document that says letter lab report, and you're going to underline it. Okay. And then read this, make sure that the format is right. And then here, down here is a memo. Okay. I think the memo, yes, right here. Okay. So memo lab report, read this, and then here is the format. Okay. So what I want you to do is to make these like top components and save them. Okay. So you can grab this image from online. There's a link in the lab report. And then you're going to write to, date, from, subject, make this line, make this section here, put this in, and then save it. And then you're done with that. Okay. So that's the memo. Here is the lab report. So you're going to have this format up here. Okay. Make sure you have that, save that. And then all the way up here, this is going to be your full lab report. And this is what you're going to have for, you're going to have this title page. You're going to have this section here, okay? An abstract, key ideas, table of contents. And then each one of these is going to be like the heading 1, introduction, materials, procedure, and all the way down, okay? And then go ahead and make, okay, here's 1.0, introduction, and go and make those on a new page all the way down, and then save those, okay? So that's the goal for lab 1. Then you will have everything set for a lab report, a letter report, and a memo. And when we get to a certain lab, I'll tell you, okay, I want a memo or I want a letter. They're gonna, some are short, some are not as long, and every different company will have, okay, you either need to do a memo or you need to do a letter, and you got to decide which one that they want sometimes, okay? Are there questions on this? Some of you might already have some of this set, but I wanted to make sure everyone was on the same page before we moved on. So this will be due, did I have it here? Right here. So I will have submission. So basically, usually stuff will be due the start of next lab. Okay. So for you, that everyone on Tuesday will be due by Tuesday, and you don't need to print these. You can actually send these to me electronically. Okay. Then we don't have to waste paper. I mean, pretty much going to, for letter and memo, what I'll probably most of the time do is have you print those because they're short, but the full lab report will probably be electronic because that'll be maybe 10 to 15 pages, okay? So in the submission in the lab, I'll tell you when they're due, okay? So this one is gonna be due next week. Let's go to lab 2. Any more questions on lab 1? Okay. The lab 2, this one, hold on, it's much easier to read. This one is Excel practice and what exactly that I want, okay, in an Excel sheet. And next Tuesday, or maybe I'll make a video and post it on here too. But I'll go through each component of what I want here. Actually, you know what? Let me see if I have this. I'll do it right now, and then you guys can be good and you can come and ask questions. Give me 1 second. Courses. 2-1, 2. I might as well show you what I've done. I don't know if I have. No. I think I actually did this one yet. No. Okay. So let me get an example. Shelley, let me download it from here. I was going to do this week, and it kind of got away from me. The supporting documents, and then problem presentation. Sorry, it's in problem presentation all the way down here, example format. Okay, so lab 2, what I'll do is I'll go get my notebook, and I can go through this, and then you can work on stuff as a good review and what you needed to do. But every Excel sheet, I will always want a header up here, okay? And then have nomenclature, and then givens, and then probably underneath this, you'll have your chart, okay? And all your calculations. So header, nomenclature, givens. If the givens are only a table, then put the table right under here with appropriate units. And always remember to, at times, center, right? Make sure you have the right significant figures. And there's borders on here, okay? And make it look presentable. Like here, I kind of bolded all of this stuff. I bolded this. It might even look better if I underlined these, right? All right. The other thing that I would want is if you click this top left and you hit Control tilde, I want you to print at times this, which gives me your equations that you use to make sure that you've done these right. Okay, so that's Control tilde. So you're going to print this, then you're going to print this, Control tilde, and then if there is a graph, you can make the graph over here, but that needs to be on a separate sheet, landscape, okay? So with lab 2, let's go back to lab 2. What you're going to do is, I can scroll right down here, is it's a good, like some review for strengths for that, have taken it, or it's a good introduction to strengths, because you're going to look at load, elongation, stress, and stuff. But you're going to have this. Here's your table. You're going to calculate the stress, and then you're going to make some plots. And then you're going to make, I think you're going to make 2 plots. Yes, you're going to make 1 plot, which is the stress strain curve. And then you're going to make another plot, which is the stress strain, but it has a linear fit. And that linear fit, if you remember, is called the modulus of elasticity. Okay. So you're going to have a table, and you're going to then have multiple columns here to find stress and so forth. Okay. So you're going to put this table in, do some calculations, make some graphs, and you're going to make it look professional with this. Okay. And then after 2 weeks, okay, we have a memo, we have a letter, or we have a full lab report. and then you know exactly how I want you to do the Excel sheets, okay? Are there questions or comments? Okay. Oh, go ahead. While you're typing, let me grab my notebook. Right here. No, lab 2 is actually doing lab week 3. Okay. Nope. I'll give you a few weeks to do this correctly. So take your time. Today I would have the rest of the class for you to work on this. Okay. And then next week, I'll review the equations that I'm going to give you right now. And then you can go ahead and work on it and have it done by the end of class. Okay. Then we'll probably start week 3 with data acquisition, temperature sensors, and maybe strain gauges, because those are used on the trusses for the bridges. And then either I'll do simple machines or I'll get into the static stuff. So no. So lab 1, let's put that in here. Lab 1, do week 2. Lab 2, do week 3. Plus, it gives you some time to settle in, you get comfortable for the semester, and make sure you're on the right track. Also, did you notice on March, what week was that? One of the weeks, the March 6th week, the first week in March, I will give you probably something to do. It might be like a literature review or something, but we will not have class because one of those Tuesday or Thursday, we're going to Fulton. So if you are interested in going to Fulton that day, let me know. I will add you to the list. Okay. But I need to, that email going out to Fulton I need to get that out actually. And we'll probably try to do other trips too. Is there any places, just random thought came to mind, that people want to go to that are local? I like to go back to Corning again. We're going to go to Fulton Boiler Works and Pulaski on March, I think it's 6. And then usually I try to like to go to 1 or 2 other places. Okay. All right. Keep that up. Let me. Oh, do I want to create a notebook real quick? Yeah, I might as well. Then I'll add everyone later. Let's see. Give me 1 second, everyone. Is everyone okay right now? I'm going to create a class notebook. And then I'll add everyone's name in after. You guys are all quiet. Actually, you know what? Give me a few minutes and I'll add everybody. I'm going to stop sharing. Let me move this here. While I'm doing this, what's everyone's plan this semester? Anything big going on? I know, Mitch, how's the bridge coming?
It's going pretty well. We're just welding up the top of finishing up welding up the top of the second half of it today.
Oh, good. Anybody else on the bridge team? Okay, guys are on robotics. How's that going? How was that meeting today? Small. Did you notice the cabinets or the cabinet? I hope. Just add your names. Good. Okay, good. What's the plan for this semester? Do you have anything? As well add everybody in the other one too. And then what is everyone other than the robotics and the bridge team? Anybody doing anything else? If not, no worries. Well, great. Oh, was Kevin there at the meeting then to tell you that we got the soccer drones? Okay, yes. So we are getting, that's going to go on 111. So probably have to rearrange that a little bit. Okay. Oh, let's add labs. And Excel spreadsheets. And you know what? Labs. Let's do this. Memos. Letter. Reports. And full report. Can I move these? Oh, come on. I'm almost ready. I'm making this. It should go to your email here in a second. Next, create. Hopefully it works. It's going to be a OneNote notebook. Some of you have been in my class before and had it, but this should come from the Canton one, but it's going to take a second here. Anybody working on the lab right now, or are you just chilling? You working on the lab? And just to let you know, this may happen again just because I live right in the snow belt. So it takes me about an hour and a half to get to school. But I will let you know well in advance. Okay, so hopefully you got something in your email from me. I'm going to open it. You have to click on the link and open it. I'm going to open it and then I'll share my screen and then I will do some notes for everybody for lab 2 so you can kind of get ahead of the game. Does that sound good? This is how I did it during COVID. I actually really, to be honest, enjoyed teaching at home. And some of you in my winter classes, this is my station here, I have like 5 monitors. Okay, so let me share my screen. It's gonna be this. Okay. Yep, you should be looking at my screen right now. This is, I'm going to turn the camera off because it's going to be weird here in a second. Where are you? There you are. Hit that. Okay. All right. So hopefully you got something in your email. Can I make this bigger? I don't know if I can look at chat. I'm doing this. Yep. Okay. I can look at chat on my phone. Did you get an email from me for this notebook right here?
I didn't.
Nothing yet? I don't know if it went to your spam. Okay. Okay, that may take a second, so we'll wait here. Let me close this, minimize that. We'll get it figured out. In worst case is I can check it later. We just have names over here. It's not a big deal, but let's pick, I'm just gonna go to MECH. So in here, I created a section that'll have class notes, Excel spreadsheets, full report, handouts. I think you can move these, yes. So I would maybe move it so they're like, let's do memos, letter, and then full report. It wasn't like this before. It was all organized. So in your name, you can have all these, and you can actually, if you wanted to, throw your homework. Like it'll have a page here. You can throw your homework right in here. Then I can look at it. That's one way to do it. You can send it to me in Teams, or you can email it to me. And I guess worst case is I have Discord. You can send it through Discord. Okay. Then there is this collaborative space that all of us can write on. Okay. It doesn't, I don't think it notifies me. Actually, I wonder if it does with this. I don't know. But I can always look. Like I'll check. Okay. So, or you can just shoot me a message. Hey, I put lab 2 in there. Okay. But I'm going to add a page, and then I can put lab 1, and then I can throw in lab 1. So give me a second. I love using Class Notebook. It's like the best thing for me. You don't have to use this at all. Okay. Versus 2, 1. Throw it in here. Let's do a printout. Okay, there's lab 1. You can do lab 2. So there are multiple places that I'll post these. I probably won't print them. I'll just post them. And then let's do lab 2 notes. We'll do that right here, okay? So let me move my computer down, and I can write on it. Okay, everyone okay so far? Fun yet? And again, I will review this on Tuesday. Or if you want to get it done, come in, hand it to me, make sure it's good. What I would recommend is send it to me, and then I'll tell you yes or no, and then fix it, okay? So what you're going to do in here, you're going to go back to lab 2. And let me just copy this. Boom. Paste it here. Okay. So you're going to make this table, and then you're going to do some calculations, okay? So you're going to calculate what we call stress. And stress we call sigma, and that's just a force over an area, okay? And I believe it gives you the diameter in here. So let me quickly turn my camera back on and I'll show you with my hand gestures what this is. Okay, can you see me now? How can I see myself? Is it working, the camera? Or did I lose everybody?
Can see you.
Okay, all right. So basically there is a, actually we can do one of these, sure. We're gonna have these little metal specimens that kind of look like this, but not really. But you could take one of these. This is like an A-arm from an RC snowmobile. And we're gonna mount this at the bottom and the top, and then we're gonna basically stretch this up, okay? And it's gonna cause, basically you have an area that you're pulling against, and you apply a certain force, it creates a stress, and then you get the elongation, which is the second column, okay? We can actually, that'd be, maybe when we get to that lab, we could do different 3D printed material. We could do PLA, we could do PLA plus, to show you some of the differences in why you would use some, okay? But basically, we're gonna take some sort of specimen and we're gonna just pull it. And we get a stress, it stretches out, so we get a strain. So that's what the elongation is. We turn this back off. You're going to calculate stress, force over area, and the diameter of that specimen is given in there so you can find the area. Strain, that is epsilon, and that's the elongation over the gauge length. Okay. And the specimen, actually, I could have drawn this, kind of looks like this, like a dog bone, I guess. And it's basically clamped here, and we're going to pull this up with a certain force. And the elongation is pretty much, we're going to look at this section that's stretching. And before it stretches, this is kind of what we call the gauge length, okay? So say it's 2 inches. That gauge length is always going to be the same, okay? Because that's the section that we're looking at that's stretching initially, okay? So we have the elongation, the gauge length is given. So you can find the strain, basically how much this thing is stretching. And then the last equation is what we call Hooke's law, which I don't think you did that in physics, right? You might have with spring forces, but we also call it sigma equals modulus of elasticity times epsilon, okay? This modulus, you'll learn in strengths or review Young's modulus. It's basically a measure of the material's stiffness, okay? That is a weird spelling. And it actually is the slope of these two. So you got sigma here, you got epsilon here. And what's going to happen is as you stretch this thing, it's going to increase linearly and then start deforming and then finally kind of break. And the slope is E here up to this point. This is what we call the yield strength. This is the section where it's linear and elastic. So as you pull this part up, it gets to this point. If you let go, it's going to come back to a certain point. Anything after this point, it's going to basically deform to a certain point where this max on this is called the ultimate stress. So you get PSI. This is actually inch over inch. So make sure you put that in. That's commonly how that's written. So these are the fundamental equations you need. And what I want is you're going to give me a plot of sigma versus epsilon, and it's going to have points like that. Okay. That's going to be your first plot. Anybody know why? Why did I say plots? Someone tell me. Or points, not plots, but points instead of a line. Okay, so anytime you do, oh, go ahead, David. Sorry. Yes, is that what you're going to say, David? I saw you were typing. Yeah, so anytime you do experiments, this is an experimental loading data, you always use plots. Anytime you calculate something or theoretical calculations, an equation, you're going to use a line. So this is going to be your first plot. You're going to have units, right? And you're going to have a title. Can someone give me a good title? Or guess a title for this? Would it be peanut butter jelly versus orange juice? Or should it be sigma, you could say stress versus strain for a particular, I don't know, I think it was a cylinder, maybe a cylindrical shape or something like that. You got to be specific. So don't just say stress versus strain. You always say stress versus strain for something, okay? And it's always the y versus the x, right? Because sigma is dependent on epsilon. So if you notice, this is the equation we're using. Sigma is got epsilon on the right side, okay? So that's your first plot. Your second plot will be this identical plot, but you're going to plot a linear line up to the yield point, and then give me that equation, which will be sigma equals E over, oh no, sorry. It'll be a number, right? Times epsilon. So you could put that equation. I don't know if I actually tell you to put that equation on, but you can. But I think I tell you to find epsilon, or not epsilon, E, which is your modulus, which is the measure of the material stiffness. Now, those that haven't taken strengths, are you okay with this? And I know it's a good review for people that have taken strengths or in strengths. You're going to be learning this ASAP. I don't know. So who is in strengths right now? Anybody? I know Isaiah, you're in statics. Hunter, okay. You've had class yesterday, right? Isaac, you're in. Okay. What did you cover yesterday in strengths? Because this is just the Excel. We'll get back to this probably after break. You might have done something with stress so far, maybe. Okay. Okay. All right. Okay, that's fine. Well, you're kind of ahead of the game a little bit. So when you get to this, you won't be so stressed and you won't strain yourself. No. Sorry. Probably like shooting a dart at my face right now. Okay. So let's recap what we did today. First, I showed you bright space, right? Everything in there is for you. Take what you need. Then I showed you Lab 1, which deals with the memos. When we get to class next Tuesday, I'll go through some safety stuff. There's no point right now to go through safety stuff, but you can read that. Lab 1, due next week. You got to give me an outline for letter, memo, and full report. And to be honest, you can throw it once you get this email and we get that figured out, throw it right in here. Okay. And then I would create a folder on your computer and label it MECH 221, Lab 1, Lab 2, and so forth. Okay. Then we looked at Lab 2, which deals with practice with Excel, exactly how I would want them professionally done. You're going to make a table. You're going to have a heading, nomenclature, a table, and then you're going to use these equations that are fundamental strengths equations and actually used heavily in machine design. And you're going to find the stress versus strain and the modulus of elasticity and create a couple plots. So I would get this done, work when you can. Send me stuff. I will let you know, okay, no, that needs to be fixed. So when we start week 3, you will be good to go. Okay, because I'll probably have you start working maybe on a full lab report for temperature sensors, because that's a pretty cool lab and very useful stuff for that. All right. Is there any comments, concerns, questions? Let me stop sharing. Are we good? Ready? Could make a t-shirt, right? How about this? If you want to take the challenge, I'll have to remember this for Thursday. It'd be really cool to make a t-shirt with strain and stress. And then maybe I'll pick the top 2 and do some sort of prize for anybody. And maybe I'll give you until week 3 to make to design the t-shirt. You don't have to print it. Because maybe you have a graph of strain and stress, and then maybe the back has my face and says "Don't stress out" or something. I don't know, but I think that'd be kind of cool. I'll put that in as a bonus for Lab 2. All right. Other than that, I'm good. Enjoy the rest of your day. If I don't make it tomorrow afternoon, I will be there Thursday. Okay. All right. Have a great day, everyone. Thank you. Bye now.